So what is the physical significance of electrical field? We saw that electrical field is nothing but is a study of how a bunch of charge will affect the space around it. Now, what is the usage of that? Right? That's what we're trying to figure out. So I'll do it here itself. Say we have a bunch of charges. We have a point A, and this has an electrical field of E. Now we have an hypothetical situation wherein we have a very huge charge, much greater than Q. We want to understand what will happen if we get it to point A. So all we have to do is, we don't have to get all of these charges. All we can do is, right, force experienced by this huge charge Q at point A, you can find it by just multiplying that Q with the electrical field at point A. As simple as that. So the physical significance is that by knowing the electrical field at a point, we can determine the amount and direction of force a charged object or a particle will experience if placed at that point. So it will help us study hypothetical situation by not actually getting that particular charge at point A. Right? It will help us study. By not wasting or spending money on that. Okay, yes. Again, I'm kind of generalizing stuff, but yeah, that's a funda. So SI unit, quite simple. So E is nothing but F by Q. So this is basically Newton Coulomb. So yes, Newton per Coulomb. Dimension. So yeah, dimension will be Newton is kg meter per second square. Charge is current into time, right? So this is ampere into second and stuff. So we have that to be in the numerator. This is denominator. So this would be, okay, let me write it over here. Mass, length, time to the power of -3 and ampere to the power of -1. So don't memorize all of this. Okay, guys. Always derive it out. It's quite simple. Is this correct? This is in the denominator. This is numerator. This bunch is in denominator because this is getting divided. So yeah, right, looks correct. Okay, so that's a bit more about your electrical field.